Our next topic is economic order quantity model. Let's take an example. Suppose you are a retailer who imports Colombian coffee from South America and sells it to local customers. Demand has been constant at the rate of 1,000 pounds a year, and the unit cost is $2 per pound. In other words, whenever you purchase your coffee from your supplier, you pay $2 per pound. The ordering cost amounts to $100 each time you place an order. The ordering cost includes shipping charges and the order processing cost. The holding costs are based on a 40% annual interest rate. How many pounds of coffee should you order whenever you place an order to minimize the total annual cost? So what's the quantity that you want to determine in this case? You want to determine the number of pounds of coffee you should order. So that's the order quantity. And what goal do you have to have in your mind when you determine the order quantity? We want to minimize the total annual cost. So what should we include to the total annual cost? You should include all the expenses that you pay as a retailer. You pay your inventory holding costs, your ordering cost, and your purchase cost. So now let's collect some information. The unit cost is $2 per pound. Let's call it U. The annual demand is 1,000 pounds. Let's call it D. The ordering cost is $100 per order. Let's call it O. The inventory holding cost per unit per year. Remember, the holding cost is based on an annual interest rate of 40%, so it's 40% of what you need to pay for each unit. So you pay $2 for each pound, so 40% of that is 2 times 0.4, $0.8 per pound per year. Now, before we determine the optimal order quantity, minimizing the total annual cost, I want to look at the following 4 scenarios and compute the total annual cost for each of these scenarios. In the first scenario, we're going to order only once a year. So the number of orders per year, N, is 1. In the second scenario, we'll place 2 orders a year. And next, 4 orders a year and 8 orders a year. And for each of these cases, I want to compute the order quantity, the order cost per year, the purchase cost per year, and the inventory holding cost per year, and the total cost per year. And let's fill this out. As you fill this out, we'll derive some formulas. Let's start with the order quantity. If you place 1 order every year, how many pounds of coffee should you order? At the beginning of this year, you order some coffee. You know you're not going to order any more coffee throughout the year. Then you need to order enough coffee that lasts the entire year. So remember, the annual demand is 1,000 pounds. So you have to order 1,000 pounds. Next, if you place 2 orders a year, how many pounds of coffee should you place an order each time? At the beginning of this year, you place 1 order, and 6 months later, you place another order. So how many pounds should you order each time? The annual demand is 1,000 pounds, so you need to split this into 2 orders. So the order quantity is 1,000 over 2, 500. Next, if you order 4 times a year, how many pounds of coffee should you order each time? The annual demand is 1,000. Split this into 4 orders. It's 250. Next, N is 8. 1,000 over 8, 125. So from this, can you derive a formula for the order quantity? Order quantity is, you took 1,000, which is D, and you divided it by the number of orders a year. So Q equals N over D, D over N. Now, can you solve this formula for n? Then you can multiply each side by n. So nq equals d, and divide each side by q. So n equals d over q. So this is a formula for n. Next, what's the ordering cost per year? First, when we place one order every year, remember the ordering cost is $100 per order. So if you order once, you pay $100 once. So 100. If you order twice a year, you pay $100 twice. 200. Next, if you order 4 times a year, you pay $100 4 times. 400. Next, if you order 8 times a year, you pay $100 8 times. Now from this, can you derive a formula for the annual ordering cost? Yes, that's 100, which was O times that's the number of orders a year, so which is n. And if you want to express this in terms of q, you can plug in this expression for n. So it's O times d over q. This is the annual ordering cost. Next, the annual purchase cost. The purchase cost is the amount of money you pay your supplier for your coffee. So how much are you paying your supplier every year? So when you order once a year, you order 1,000 pounds, and each pound costs $2. 1,000 times 2, 2,000. Next, if you order twice a year, then each order is 500 pounds, but in total, you order them twice. So in total, you order 1,000 pounds. And each pound is $2. Next, if you order 4 times a year, each order is 250 pounds, but you order them 4 times. So in total, you order 1,000 pounds. And then again, 1,000 pounds and $2 for each. Now, can you derive a formula for the purchase cost per year? Regardless of the number of orders per year, you pay 1,000, which was D, and you multiply it by 2, which was the unit cost. So this is the formula for the purchase cost per year. Okay. Next, inventory holding cost. How much should we pay for the inventory holding cost? We know the inventory holding cost per unit per year is 80 cents, but we need to multiply this by the number of pounds we hold in inventory. So how many pounds do we hold in inventory? So one thing that's challenging is that the inventory level is changing over time. So let's say the x-axis is the time, the y-axis is the number of pounds you hold in inventory. When you order once a year, at the beginning of a year, you order 1,000 pounds, and over time, you keep selling it. And at the end of the year, you have 0 pounds. So this is what happens in the first year. And this is repeated over and over again. So what's the holding cost? It's 80 cents per pound a year. And should we multiply it by 1,000 because we have 1,000 pounds at the beginning of a year? Or should we multiply it by 0 pounds because we have 0 pounds at the end of a year? The answer is meet halfway. Compute the average of these two. 1,000 plus 0 divided by 2, 500. And multiply 80 cents by 500. So the inventory holding cost is 80 cents times 500, which is $400. So why should you use this average? Because the average of these two is the average of the inventory level over time. So for example, if we draw a horizontal line at 500, so is this area the same as this area? Yes, they're symmetric, right? So you can take this and put it here. Also, is this area the same as this area? Yes, symmetric. So you can take this and put it here. So this level is the average level, inventory level throughout the year. And you multiply it by 80 cents. So we computed the inventory holding cost per year when n equals 1. Next, when you order twice a year, what's the inventory holding cost? So its holding cost is 0.8 per pound per year. Should we multiply by? So what happens at the beginning of this year? We order 500 pounds and we keep selling it. 6 months later, we run out. We order another 500 pounds and we keep selling it. At the end of the year, we run out. So should we take 80 cents and multiply by 500 because it's the inventory position at the beginning of a year? Or should we multiply by 0 pounds because we have 0 pounds at the end of a year? The answer is compute the average, 500 plus 0 divided by 2, 250, and multiply 80 cents by the average inventory level. So it's 80 cents times 250, that's 200. So why is it possible? Because if you draw a horizontal line at the average inventory level, we can take this area, put it here, take this area and put it here. So this inventory level is actually the average inventory level. So we can keep doing this for the rest of the cases. And at this point, can we derive a formula for the average inventory level? Yes. It's Q, the beginning inventory, plus 0, the ending inventory, divided by 2, so it's Q over 2. How about the holding cost? Can we derive a formula for the holding cost? The annual holding cost? Yes. We take H, the holding cost per year per unit, and times the average inventory. The average inventory is Q over 2. So that's the formula for the annual holding cost. So how do we compute the total cost per year? It's the sum of these three costs: ordering cost, purchase cost, and inventory cost. Now, so we found the total cost per year for each of these scenarios. And according to this table, what order quantities should you choose? Which one generates the least total cost? 2,400 is the least annual cost. So that means we need to place 2 orders a year, and each order is 500 pounds. Now, in this table, we looked at only 4 cases. Are these the only cases that are possible? Or can we order different amounts? Can we order different amounts? There are other possible values, so what we really need to do is look at all the possible scenarios and compute the total annual cost for each of those scenarios and choose the one that gives us the lowest cost. And that value is the optimal order quantity. So in other words, we need to look at all the possible values for the order quantity. For each of these values, we need to compute the total annual cost, and we'll have something like this. And we'll choose the value that produces the least annual cost. And that order quantity will be the optimal order quantity. But that's going to take too much time. We can't do this every time we have a problem. The good news is people already found the formula for this optimal order quantity, and it's given by the square root of 2 times O times D over H. And this is referred to as the economic order quantity value, the EOQ value.